is one of our staff, the expert of tsunami. He said 20 centimeters sand was accumulated by the tsunami, almost all the Sendai Plain area. This is one of the fisheries on the agricultural city in Sendai, Arahama. The school, only school, is remained. And from the urban planning viewpoint, including school and this town, village, this area is so-called urbanization control area. That means normal building cannot be constructed except the residents, for residents from the past. So basically, if the regulation is very strictly preserved or followed, these towns in the so-called 調整区域 will not be grow so much. And this is one of the typical picture. This is maybe city-operated rental houses. Backside of tsunami flow, some of the houses, even as detached wooden houses, remained like this. But we need analyze more details because of what. Excuse me. This is more the similar picture that was shown by Fukushi Sensei. And this is Arahama Elementary School. And I took this picture inside of the classroom, Arahama Elementary School. And this is the picture from the gym of this elementary school. And lastly, I'd like to show the Sendai Airport Station. You can see the trace of tsunami here. Just the same level of the airport. The tsunami trace can be seen very clearly in some places, maybe even now. This is the Fukushima area, Iwaki City, almost 30 kilometers from the Fukushima Daiichi nuclear power station. So it's a limit of the investigated area. And tsunami struck here almost 5 or 6 meters height, and some of detached houses remained. This is the fort, also in Iwaki City. He's an expert of tsunami, and he introduced this place inside of the Iwaki City. This fort appeared. It's not kind of main earthquake, but the aftershock caused this fault line. More than 1 meter's displacement means larger than the Kobe case. In case of Kobe, Nojima fault is just 60 centimeters. And this is the last picture of the Onahama port of Iwaki City. And this is a kind of rough image of the power of tsunami. Before this disaster, in the building field, we have prepared one guideline of the tsunami kind of anti-tsunami building design method. But we need rethink again because of the this case that estimated tsunami height is less than 5 meters. But in case of 10 meters or more than 10 meters, we need to think about again. And the conclusions, this is the conclusion of National Research Institute. it was observed that the structure damage to buildings was not so significant on the whole, even in the areas where seismic intensity more than 6. The 7 is the maximum in Japan was recorded. This means that the current seismic design in building standard law of Japan is generally appropriate for the seismic-related damage mitigation. This is more common sense of the most building expert in Japan. But I have a really different viewpoint. Most of the reinforced concrete buildings suffering from seismic damage were found to be designed by the old seismic design method, which had been valid until 1981. In this year, the Japanese building standard law improved its seismic building code, and damage to suspended ceiling in steel gymnasium was observed. This is the new, or even one of the characteristics of this time. And also, the earthquake caused liquefaction of soil more extensively than the recent earthquakes did. And also, typical types of tsunami-induced damage to buildings, such as turnover and swept away of entire structure, were observed, and we need to investigate more. Finally, I just introduced some of the kind of website of the Kenken Building Research Institute. Yeah. Thank you very much.
Thank you very much, Professor Kato. Yeah, we can have the couple of questions. Yes.
Thank you for your presentation. In your last slide, you mentioned that you didn't agree with the common sense of structural engineers was that the building codes were sufficient, and you say you didn't agree with that?
Yeah.
In which sense you don't agree?
Yeah. First, the intensity of the seismic intensity, formerly it was decided by the damage of building or damage of structure. But recently it is calculated as a kind of automatically. So we need, even the acceleration is very high. The frequency is another important factor. Frequency of strong motion. So in case of Tohoku University, the top of hill, the frequency of that area was almost 1 second or 1.5 second, the main frequency, and 8 or 9 or 10-story building is the mostly affected by that frequency. In case of super high-rise building, like 60-story or 80-story, 5 second or more longer second. So long-term frequency will be dangerous. But in case of detached houses, there's almost 1 second is the kind of dangerous frequency in the most of the buildings. But this time, more 0.5 second or such kind of short frequency is the main element of the acceleration, recorded acceleration. So it needs kind of another interpretation of the or the relationship between the seismic intensity and damage of building should be rethink. And another issue is this case is not kind of the case of the Great Hanshin Awaji earthquake. It was kind of under cities earthquake, and in case of Tokyo, we also should be prepared well for the kind of under city earthquake, it may cause another damage. So even though for example, more than 1,000 gal, most of the building was survived in this case, we should prepare, or we should be more careful in terms of those two aspects.
Thank you very much. Yes. But this is the last question. We do not have enough time, so please consider this situation.
Hi, thank you for your presentation. I think it's approximately the same subject. I was wondering, if you say that maybe we're not ready, or maybe we should prepare more, is there any plans for example, retrofitting existing buildings, or maybe strengthening buildings that were maybe built with previous codes, older codes?
Okay, the preparing from the viewpoint of the building structure against the next earthquake, especially for existing building, especially for buildings that was constructed before the new standard, that means 1981. The national government established new law of the retrofitting immediately after the Great Hanshin Awadi earthquake in 1995. However, and also recently, the national government prepared a tax exemption of the repaired cost, the national tax exemption. However, the number of retrofitting is not so increased. Maybe, as far as I know, if the owner of a house or old house have sufficient money, they tried to repair not structure part first, but kitchen or bathroom that the wife of owner would like to repair. So that's social or the kind of challenge for the policy from the viewpoint of the policy issue. But it's not only in Japan, but almost all the part of the seismic area of the world. We need try to cooperate how to solve this challenge. And I experienced in the case of Nepal, the ladies tried to repair their houses against an earthquake, or housewives, because in case of Nepal, most of housewives stay in home, not work outside. So they need to repair houses after they saw some damages of Pakistan or other countries around there. And they are expecting the next earthquake. Especially Nepal is located in between Sichuan and Pakistan. And anyway, in that case, ladies also informed their relatives or husband to repair the house. That's very strong movement. So I think how to motivate the housewives is one of the key for the repair of the seismic house.